Hello, welcome to Block 1 Sequence Lesson 7. I'll share my screen. In your previous lesson, you learned how to continue numeric nonlinear sequences. And in that lesson, I used the word rule. So I introduced that word and I said you're going to come across the word. So term to term rule refers to being able to describe a sequence. So you have been doing what we're going to do today, but it's just that we're making it more robust. So we're linking it to everything you had learned before. But before we start, I would like you to do this retrieval practice, which will take 3 minutes. Okay, we have 1 minute remaining. Okay, let's check our answers. So here we're asked to continue the linear sequence. Now you can clearly see that this number is, we're adding 3 every time. Yeah, it's quite obvious that we're adding 3 every time. Okay. Sorry, not 3. We're adding 7. Okay. We're adding 7. Sorry about that. So we're adding 7 every time. So you can clearly see that. I don't know what made me think about 3. Anyway. Okay. So we're adding 7 every time. So to continue the linear sequence, you would have this. Okay. You would have this. All right. So you add 7 to 18, you have 25. And then here you can see that we're halving the number every time. Okay, so half of 128 is 64, half of 64 is 32, half of 32 is 16, so on and so forth. And then you need to continue the sequence until you find the term where it will be less than 1. Okay, so you see we have 1, 2, 3, 4, 5, 6. So the sixth term is 4. The seventh term, if we have it, will be 2. All right. And then the eighth term, if we halve it, it will be 1. And then when you have the ninth term would be 0.5. Okay, half of 1 is 0.5. So the ninth term is where you would have it being less than 1. Okay. All right. Let's do some new learning. I think I'm going to have to rub this off so it doesn't. Okay. All right. If I give you this, this sequence, and then you're asked to describe how the sequences change from one term to the next, you could say subtract 9 each time. Okay. That way, you have just stated the rule that is creating the each terms of the sequence. So you start with 75, you subtract 9, and then you subtract 9 again, you get 57. So this is the rule. Okay. Remember, the title of our lesson is to explain the term to term rule of numerical sequences in words. Okay, so we're going to be using words like this. All right. Now, this one you can see you have 2, 6, 18, 54, 162. So I want you to have a think. What do you notice about this? And I want you to also think, is there only one way to describe a sequence, the rule of a sequence? Is there only one way, or is there more than one way of describing the term to term rule of a sequence? Okay, 10 seconds. All right, so this one you can see we're simply multiplying the previous term by 3. Okay, all right. So here is this sequence 4, 6, 9, 13.5. Mo says that the term to term rule for the sequence is to multiply by 1.5 every time. So we're multiplying the previous term by 1.5. I'm sure the way he found that was to divide. Okay, the way you find that is to divide 6 by 4. If you divide 6 by 4, you have 1 remainder 2 over 4, which will be 1.5. Okay, if you divide 9 by 6, you get the same thing. Okay, you have 1 remainder 3 over 6. This is the same thing as 1.5 because 3 over 6 is a half, so it's 1.5. So Mo has described it one way. Okay, that's one way of describing the sequence. But I need to tell you this, and you should know by now that you can describe a sequence by more than one term to term rule. All right. So Eva says that the term to term rule for the sequence is to add half the previous term to find the next term. So if we add half the previous term to find the next term, we'll get the sequence. So if we add half of 4 to 4, we'll get 6. If we add half of 6 to 6, we'll get 9. If we add half of 9 to 9, we'll get 13.5. So they are both correct. So what you really need to know from these exercises is you can describe a sequence with more than one term to term rule. So let's say you're working in class or you're working in a group with your mates and somebody else describes a sequence differently. Don't be surprised if you're both correct. Okay, I want you to have a go at questions 1 to 3. This should take you 5 minutes. Don't worry if you can't finish in 5 minutes. Work at your own pace. What is important is really understanding the maths. You can obviously pause the video and take a longer time to do the work. Okay, we have 2 minutes left. Okay, let's check our answers. So the first one, we're told, describe how these sequences change from one term to the next. And then you ask, after you describe that, you need to state whether they are linear or non-linear. So we'll just check a few of them. So this one, you can clearly see, let's start with this one. You can clearly see that that one, we add 3, and then we add, um, and then we add 4. Okay, so the number by which we're adding every time is increasing by 1. And then for question 2, you can see this one is clearly linear. So sorry, let's look at 1E. So we're adding half every time. So you can see that is clearly linear because we're adding the same amount every time. That one is not linear because straight away you can see D is not linear. You can see that you added 3 to get from 4 to 7. And then now you have 7 to 11, which is you added 4. And then 11 to 18, which means you added 6. sorry, you added 7. Okay, so you can see it's clearly not in linear sequence. We're not adding the same amount every time. And then question 2, you're asked to describe, to state the what mistake Rosie made. So you can clearly see that you start by 4, you're told to multiply. So the next term is found by multiplying the previous term by 4. So what she was doing, the mistake is she was clearly just adding 4. So that's a mistake she made. And then here for the third one, you're asked to describe the sequence a different way. All right, so here are some possible answers you could get. All right, so here are some possible answers. So for A, it's linear, you subtract 8 each time. B is non-linear, you're dividing by 2 each time. C is non-linear, you multiply by 3 each time. D is non-linear, you total the two previous sequences, differences, and then add to the previous term. Then E is linear, we're adding half each time. So, of course, number 2, like we said, Rosie has added 4 each time. So instead of multiplying by 4, or Rosie has been multiplying the position number by 4 rather than the previous term. So position number will be position 1 by 4, position 2 multiplied by 4. So possibly that's what she was doing. And then question 3, you double the previous difference and then add onto the previous term, or double the previous term each time. I would rather describe it the last way, so we double the previous term each time. Okay, so if we have a sequence like this, right? So we have 1, 1, 2, 3, 5, 8, 13. You think, wow, this is an interesting sequence. What's going on here? Okay. Would you be able to describe how this sequence changes from one term to the from term to term? Have a think. Okay, this is a Fibonacci sequence. So I want you to really take note of this sequence because you're going to use it again and again and again so many times. You're going to be using it even in year 8, in year 7, in year 9, in year 10, And for those of you who will move on to do A-level math, you'll see it again. So the way it works is the Fibonacci sequence starts with 1, 1. So you just start with 1, 1. And then to get the next one, you add the previous 2 terms. So if you start with 1, 1, 1 plus 1 is 2. To get the next one, you add 2 plus 1. Okay? So this is how we generate the sequence. Okay? 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. Okay? So on and so forth. So to get the next term in the sequence, you add the previous 2 terms. And that is what we call a Fibonacci sequence. What do you think? Do you think it's linear or non-linear? Well, I think it's non-linear because remember what we said about a linear sequence. A linear sequence is a sequence where you have a constant difference. So the number by which you're adding every time is the same, or you're subtracting every time is the same. Okay, so it is non-linear. Now, sometimes you can have sequence that, you may think, wow, this sequence looks somehow strange, but it's not, because remember in our previous lesson, I said you can use 2 operations, math operations, to describe a sequence. So for example, this one, I could say, well, 204, okay, 100. Well, we could describe it by saying, if I have 204, I'm going to get 102 and then subtract 2. So we can describe this sequence as halve the term and subtract 2 to get the next term. Halve the term, so if I have 100, I'll get 50. 50 minus 2 is 48. If I have 48, I'll get 24. 24 minus 2 will be 22. So we can think about it that way, but someone else might think about it differently. Someone else might say, of course, it's not a linear sequence, you should know. Someone else might say, um, subtract 4, then divide by 2 to find the next term. Okay. Or someone might describe it the way I described it. This divide by 2, then subtract 2 to find the next term. So you need to know that what we've learned so far in these short exercises, you need to know that it's possible to describe a sequence in words using two different math operations. So for here, you see we're describing a term with subtraction and then division, and then subtraction. Okay. All right. Have a go at the rest of the questions. So you have question 4 to 6. That should take you 5 minutes. Okay, we have 2 minutes remaining. Okay, let's check our answers. So the first one, we're told the first two terms of a Fibonacci sequence are 1 and 1. The term to term rule is to find the next term, add the two previous terms together. So we discussed it. That is how you generate a Fibonacci sequence, or let me add something, a new word, Fibonacci-like sequence. And I'm going to explain what that means. So to write the first, so write the first seven terms of the sequence. What is the first term that is greater than 30? So in this case, all you need to do is just to keep generating the sequence. Okay. So to generate the sequence, you say you have 1, 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. That's how you keep going until you find the term that is greater than 30. Now, let me talk about Fibonacci-like sequence. What if I said, oh, I want you to generate a Fibonacci-like sequence when the first two terms of the sequence is 0, 1. Okay? So you can generate any Fibonacci-like sequence when they give you the first two numbers of the sequence, but you have to follow the rule the way we generate a Fibonacci sequence, an actual Fibonacci sequence. And what is the rule? How do we generate Fibonacci sequence? By adding the previous terms to get the next one. So 0, 1, 0 plus 1 will be 1, 1 plus 1 will be 2, 1 plus 2 will be 3, okay, 2 plus 3 will be 5. You see? So you can say, oh, but that looks like this one. Yeah, because actually we can start with 0, 1. And when you study further, you would see that your computer works with 0, 1. Okay, let's move on. For question 2, you there are quite a lot of statements here, trying to describe a sequence that is just 1, 3. Remember, there was a lesson where we looked at a particular question and we established that you can describe a sequence properly if you have 3 terms. So all these guys, Whitney, Annie, Teddy, and Alex, they could all be right because remember, in one of our lessons, we said we need 3 terms to be able to describe a sequence properly, because you could have many people saying different things and then being correct. And then the third one, the last one, we have a sequence that starts with these numbers, and then you're told to describe the 2-step term to term rule. So remember the 2-step term to term rule, you can use different maths operations to describe the sequence. Remember, we have 4 maths operations. It's either you're adding, you're subtracting, you're multiplying, or dividing. So always take note that you can use 2 step rule to describe a sequence. Okay. All right. Let me show you the answer so that you can actually mark your work and then learn from your mistakes. We're always learning. We're always learning. Even Mr. Oteri learns every day. So here are the answers. Mark your work, please. So for question 4, you can see the 9th term is 34. So it is the 9th term that will be greater than 30. Question 5a, they could all be correct. You see, like I said, because a minimum of 3 terms are needed to determine the term to term rule of a sequence. So for B, Whitney, is describing a linear sequence. Sorry, let's go back. Whitney is describing, just a minute. So Whitney is describing, they're asking you which of these, Which children are describing linear term to term rules? It's Whitney. You can see Whitney says the term to term rule is add 2 to the previous term. And then see which children are describing nonlinear sequences. It is Teddy, Alex, and Annie. Why? You can see what they said. Yeah. They said the term to term rule is double the previous term and add 1. You can see they're using 2 steps to describe. And then Teddy is saying the term to term rule is multiply the previous term by 3. And then here the term to term rule for Alex is multiply the previous term by 4, then subtract 1. Okay, and for the last one, multiply by 2 and then subtract 100. Okay, that brings us to the end of our lesson today. So what we've learned so far is you can use words to describe the term to term rule that generates a sequence. Now, you can use two-step rule to describe a sequence, and you can also use one step to describe a sequence. However, what is important is observing the sequence to see how the numbers interact with each other from term to term, and then that will determine how you describe the sequence. So remember, we have covered in this lesson how to describe the term to term rule for a sequence in words. Okay, until next time, take care and bye bye.